Once again, the mole is a concept, and mole is used to represent the quantity in a chemical reaction. For example, now the mole definition, it has been discovered 6 multiply 10 raised to power 23 particles of any element always weigh the same as its molecular mass. What does it mean? It means that, for example, you have the periodic table. In the periodic table, the mass of carbon, the relative atomic mass carbon is 12. What does it mean? It means that this 12 gram equal to 1 mole. If you take carbon, how much carbon you take? 12 grams. So that equal to known as 1 mole of what? 1 mole of carbon. For example, if you see the periodic table, let's say sodium. In the periodic table is written 11 and 23. Its mean relative atomic mass of sodium is what? 23. So if I will ask you that mass of 1 mole of sodium equal to how much? So I just put grams with it. So it is equal to 23 grams. So see here again, they're saying that it has been discovered that the element always weighs the same as its molecular mass. Now they are telling a number here. 6 multiplied 10 raised to power 23. So just try to get this concept. They're saying that if you have 1 mole of any substance, for example, 1 mole of carbon, 1 mole of hydrogen, 1 mole of sodium, if you will count the number of atoms inside 1 mole, so they are equal to these numbers. 1 mole of carbon has how many atoms? 6 multiplied 10 raised to power 23. 1 mole of sodium has how much atoms? Same, 6 multiplied by 10 raised to power 23. I will give the example. For example, if uh, you are Sudan, both of you are from Sudan. Ahmed, please confirm.
Yes.
Okay. You use a word dasta. If you want to go to the market, they'll say, I need 1 dasta apple. Apple 1 dasta. What do you mean by dasta? Doesn't mean 12 pieces. Am I right? Yes,
Yes.
Ahmed. Okay. Now, if I will say to you, okay, I need 1 dozen what? 1 dozen, I need orange. Okay. So you will go and you will bring 12 pieces. If I say I need 1 dozen of banana, or you can say mango. So what you will do, you'll bring 12 pieces of mango. Tell me, what do you think? The 12 pieces orange will be same mass like 12-piece mangoes or different? Yes, Ahmed. Their mass will be different or same? 12 oranges and 12 mangoes, they have the same mass?
No.
No. In the same way, when you're talking about mole, when I say mole of sodium, then mole of magnesium, the number of atoms are same in both. 1 mole of sodium has 6 raised to 10 raised to power 23 atoms, and it also has 10 raised to power 23 atoms. Same like 12 pieces, 12 pieces. So number of atoms are same, But when you talk about the mass, the 1 mole of sodium has mass what? 23 grams. 1 mole of magnesium has mass of what? 24 grams. Like this. Mole of any substance, it has the same number of atoms. But if you talk about the mass of 1 mole, it is different. And how do you know that? For example, if I ask to you, okay, Ahmed, tell me what is the mass of 1 mole of lithium. So what you will do, you just go to periodic table and you see the relative atomic mass. It is 7. So you will say, okay, lithium 1 mole equal to what? 7, and you put just grams. So this is the mass of 1 mole of lithium. So just see the periodic table with the relative atomic mass, just put gram. So it's known as relative atomic mass, or this is the mass of 1 mole. Now, for example, what is this number? When we said that every mole of any substance has 6.6 multiplied 10 raised to power 23 particles. So this number is known as Avogadro's constant. He was a scientist and he gave this law that any mole of any substance, if you count the number of atoms in that mole, all the moles they have the same number of atoms, so that same number is known as Avogadro's constant. So you should know that if in the exam they will ask what is the value of Avogadro's constant, so you will say 6 multiplied 10 raised to power 23. So it means that a mole is what? 6 multiplied 10 raised to power 23 of particle, atoms, or ions or molecules. They can be atoms, they can be molecules, they can be ions. For example, if I will say to you that 1 mole of sodium, so how many atoms are there? 6 multiplied 10 raised to power 23 atoms. If I will say to you that there is 1 mole of NaCl, so at that time, what you have molecule. I will say 6 multiplied 10 raised to power 23 molecules. If I will say 1 mole of sodium ion. So what does it mean? How many? 10 raised to power 23 ions, like this. So they can be atoms, they can be molecules. It depends on the substance. If it is an element, you use the word atoms. If it is a compound, you use the word molecules. Or if it is in an ionic form, you can say ions. So this is, for example, here they're getting that if they will take 1 mole of carbon, its mass is 12 grams. So this is the concept of the mole. Did you get this one? Please confirm. Yes, Ahmed, is it easy?
Yes.
Okay. Now we will see the conversion of moles. How you can find the mole of a substance. How you can find the mole of a substance. It's really easy. Now you can divide these mole conversion into categories. Number one, category number one, mole and elements. For example, I will say to you, I have 46 46 grams. 1 minute. I have 46 gram of sodium. Now they gave you this one. How many moles are there of sodium in this 40 gram? How many moles of sodium are there? So simply, what is the formula? Mole equal to mass over AR. relative atomic mass. Relative atomic mass. Okay. For example, what is the mass given here? Mass is given 46. You will write 46. Now see the periodic table. What is the relative atomic mass of sodium? That is 23. So divide it. So answer will be 2. So it means that in 46 gram, if they will give you 46 gram of sodium, how many moles of sodium will be there? 2 moles. Once again, for example, they give you mass of sodium. They said that you have 50 grams of sodium. How many moles are there? Again, what is the formula? Mole equal to mass over AR. What is the mass? 50. AR is what? 23. When you divide it, so if you see the with the help of calculator, so it will be 2.17. 2.17 moles. So if they are talking about only element, sodium, calcium, magnesium, chlorine, oxygen, only one atom. When they talk about atom, so mean the element. So you will just divide the given mass, then equal to divide by its AR. So it will get the moles. Now, if they will find differently, for example, they'll say to okay, there are 3 moles of what? Carbon. Find mass. What is the formula we're using before? Mole equal to mass over AR. But here, mole is given. What they need? They need mass. So change this formula into mass. So what will happen? New formula will be mass equal to mole multiplied by AR. So what is a mole? How many? 3. What is AR of carbon? 12. So answer will be 36 grams. If you want to write this formula, you can write the formula in this triangle form. For example, if you want to write this formula, you can write this formula in this form. For example, here you will write mole multiply, you will write AR divided by mass. For example, if you want to find the mass, what will be the formula? Mole multiplied by AR. If you want to find mole, formula will be mass divided AR. If you want to find AR, formula will be mass divided by mole. So it depends on the data which is given to you. According to that, you can use the formula and you can find the number of moles. Once again, another example I will give you. For example, they given you 48 grams of magnesium. They have given this one. And what you have to find, how many moles are there of magnesium. So what is the formula? Formula of mole equal to mass divided by AR. What is the mass given to you? That is 48. What is AR of magnesium? 24. So when you divide it, so answer will be 2 moles. Is it clear, Ahmed?
Yes.
Okay. So this one we are talking about what? We were talking about mole and elements. When only mass of element is given and they need the moles of the element, then you will use this formula. But if they have a compound, okay, if they have a compound, for example, what? For example, they said that 100 grams of what? NaCl. This NaCl is not an element now. NaCl is a compound. So how many moles are there in 100 grams? How many moles of NaCl? So you will find that. How you'll find? Formula is same. Once again, but now what we are doing? We are doing mole and compounds. So what is the formula? Same. Mole equal to mass over mr. Before you were doing AR because that is only one element. Now you are doing MR, mean molecular mass. So it means that you have to find MR of NaCl, then you can use the formula because mass is given, that is what 100. Only you need MR. How to find MR? Remember in the previous lecture we did what is a MR of NaCl? What you will do? Which atoms? Na. How many atoms? One. Chlorine, how many atoms? One. What now for sodium? What is relative atomic mass? 23. What is relative atomic mass? 35.5. So what it will be? 23. It will be 35.5. If you add it, it will be 58.5. Now this is the MR of what? NaCl. Now you will use the formula mass over MR. Mass is given 100. And what is MR? We just found it now because this is a compound, not a single element. So that is 58.5. So when you do this one, so if you will divide it, it will be 1.70. 1.70 moles like this. So only change in this formula as compared to the previous formula, only MR. Before you have AR for the element, but now you have a compound, then you have MR. So only this is the change. If the mass is given of any compound by using this formula, you can find its mole. If moles are given, you can find its mass. If the mass, you will find formula will be changed like this: mass equal to mole multiply mr, like this. Any confusion?
No.
Okay, so now the first thing we finish, what we finish? Mole and elements. And what was the formula for that? Mole equal to mass over AR. Second thing we finish, mole and compounds. What was the formula for that? Mole equal to mass over mr. Now, third thing we have the mole of a gas. If a gas is given, if they say to you that there is a gas, carbon dioxide gas, or hydrogen gas, or oxygen gas, any gas, how you will find its moles? So the third step is the mole and gases. It's really easy. If they will give you this type of question, so what is the formula for that? Mole equal to volume divided by 24. Now If they will say to you, there is a gas, for example, question is what? You have that 72 cubic decimeter of what? Oxygen gas. So how many moles are there of oxygen in 72 gram volume? So you will simply mole equal to volume over 24. What is volume? 72 divided by 24. So you do it. So 3 moles are there. So mole of a gas is really easy. Just you need the volume and divide by 24. 24 for any, whether the gas is hydrogen, chlorine, oxygen, nitrogen, any gas, all you will just divide it by 24. But make sure the volume which is given here, it should be in cubic decimeter. If it is in centimeter cube, just divide it by 1000. So it will convert into cubic decimeter. For example, if they will give you that there is a gas and its mass, its volume is 50 cubic centimeter. But what we need cubic decimeter. So how you will convert 50 divided by 1000? So answer will be what? 0.050. Now it's become cubic decimeter. So then you will use it in the formula, only this thing. So now we did the mole and element. This is the formula. Mole and compound. This is the formula. Mole and gas. This is the formula. So these are three things. So is it clear how you can find the mole of a gas? Please confirm.
Yes.
You can see here they have given the formula and they have given the question. So one thing maybe you will notice in the formula, they wrote N. Now they are using symbol. Mole symbol is N. Instead of writing mass, they are using capital M. For volume, they are using V. Again, N means what? Moles. So just you should know for how to convert. If cubic decimeter, you want to convert into cubic centimeter, multiply by 1000 or 10 raised to power 3. 10 raised to power 3 means 10 multiplied by 10 multiplied by 10, and it's equal to what? 1000. So 1000 can be written in this form also. And if you want to convert cubic centimeter into decimeter, divide by 1000, and just we did now. So this is how you'll find. For example, they have given here what is the mass of 3 moles of water. Now, which category it is? Now tell me, this water is what? Water is element, water is compound, or water is a gas? Yes, Ahmed, tell me, in which category you will find it? Water is element, what is a compound, or what is a gas? Tell me.
Compound.
Compound.
Or
So for compound, what is the formula we discussed before? If you want to find the moles, mole equal to mass over mr, because it's a compound. But here they need the mass. So we change the formula. Mass equal to mole multiplied by mr. Now moles are given, that is 3. But what is the mr of water? For that, how you find the mr of water? So for example, this is the water molecule. You will write hydrogen how many? 1. Sorry, 2. Oxygen how many? 1. So what is the relative atomic mass of hydrogen? 1. So 1 multiplied 2, 2. Oxygen how many atoms? 1. But what is relative atomic mass? 16. When you multiply by 16, you will add them. So this is 18. So 18 is mr of water. So multiply by m18 here. So what is the answer? 54 gram. So this is the mass. Now for gas, you see they have given one question here for the gas. For example, they ask here that there is a gas, and which gas? Oxygen. So what is this? 480, what is that? That is volume. And what they need? Moles. And so what is the formula? Formula is, if you want to find the mole equal to what? Volume divided by 24. But as I told you that volume should be in what? Decimeter cube. But it is given in what? Centimeter cube. So you will divide 480 by 1000. So you will get the answer in decimeter cube. Now you will put this one here. What is the volume? 0.48. And divide by what? 24. So when you get this one, so what is the answer you get? 0.02 moles. So these 0.02 moles of oxygen are there in this much of oxygen. Is it clear?
Yes.
Okay. Now another question, that if you have now they have given volume, and now volume is what? Already in what? The cubic decimeter. But this time what they need? They need mass. Mass of what? Neon gas. So for first of all, you will find the moles, because if you see the gas formula, what is the gas formula? You have mole equal to volume divided by 24. In this formula, mass is not there. Mass is in which formula? Mass in the formula mole equal to mass divided by AR. So it means in this question we use the two formulas. By the first formula, you will find the moles. So how you will find that one? See, for example, what they have, neon gas, volume is given, that is 2.4, and mass they want to find. So first you'll find the moles. Moles equal to volume divided by 24. What is the volume? 2.4, and divide by 24. So what is the answer you get? 0.1 mole of what? Neon. Now use this mole in the other formula. What was the other formula we just discussed now? If you'll see, we said that mole equal to mass over AR. Why we are using AR? Because neon is single. So, but we need mass here. So, formula will become mass equal to mole multiplied by AR. So what is mole? We just found 0.0, 0.1. And what is AR of neon? Neon is 20. In the product table, you can see this one. When you multiply, you will get 2 gram, and this is the mass. So sometime in a question, you have to use two formulas instead of one. So how you will do this one? It is given here. Okay. Now they have used the term here, that empirical formula and molecular formula. What is the difference between them? So this is really easy. Empirical formula shows you simplest ratio. For example, the empirical formula is the one that show simplest ratio of elements in a molecule rather than the total number of atoms in this molecule. For example, now see, they have given a formula here, P4H10. For example, if I wrote this formula here, P4H10. Got it? Now, which two elements are there? You have phosphorus and you have hydrogen. How many phosphorus? 4. How many hydrogen? 10. So this is the ratio between them. 4 phosphorus and 10 hydrogen. Can I simplify this one? Can I divide both by 2? If I divide by 2, this one also divide by 2. What I will get? 2 and 5. Can I simplify further? No. So if I will write that P2H5, this one. So then this is known as empirical formula. Empirical formula will show you simplest ratio. It is not give you exact number, because exact number is what? 4, 10. But here you have 2 and 5. So once again, see the empirical formula definition. Empirical formula is one that shows the simplest ratio of elements in a molecule rather than the total number of this one. So sometime if the formula is given to you, you can make its empirical formula. For example, this one, C10H22. So if you can divide by both by 2, so you will get C5H11. Now you cannot divide both with the same number, so it will remain here. But sometime, for example, water. What is the ratio of water? Hydrogen 2, oxygen 1. Can you simplify it further? No. So for water, this is the molecular formula and this also empirical formula, because you cannot change it further. So sometime molecular formula is same like empirical formula, because you cannot simplify it further. So this is the method how you can find the empirical formula from a molecular formula. It's really simple. And now they have given another example, C6H12O6. So all the numbers you can divide by 6. So answer will be CH2O. So this is the empirical formula. Molecular formula is a formula that shows actual number of atoms in molecule. So here, if you see this formula, how many phosphorus has 4, how many hydrogen has 10. So it will give you exact number of atoms present in this substance. Okay. Now, this is easy question. Just you have to put some concentration. Now, in the exam, they will give you a situation. They will say to you that there is a compound. There is a compound, you don't know what is the compound. They just gave you a compound. But what they will tell you that elements which are present there. For example, they will say to a compound, there is a compound, but they will not give you the formula of the compound. But they will tell you, yes, there is a compound, it has carbon, it has hydrogen, and it has oxygen. So they are giving you a hint that there is a compound. Inside that compound, which elements are there? Carbon, hydrogen, oxygen. Maybe they can say there is a compound, there is hydrogen and sulfur. So they can give you any elements. And then first thing, what they will give you? Element. Number two, they will tell you the percentage of each element. For example, they can say in this compound, carbon is 25%, hydrogen is 25%, and 50% is the oxygen, because total should be 100% if you add all of them. Or for example, if the elements are hydrogen and sulfur, maybe they can say hydrogen is 30% and sulfur is 70%. Total is 100. So the first thing they will tell you which elements are present, and second thing, they will give you percentage, or sometimes they will give you the mass. For example, they can say carbon is 20 grams, okay, hydrogen is, let's say, 40 grams, and this one may be 40 grams. So first thing, they will tell you the elements, then they give you the percentage, or they will give you the mass. Then with the help of this information, you have to find the empirical formula of that substance. How? We'll solve one example here. Now see the example. They said that a compound contain 38.7% of carbon, 9%, 9.75% of hydrogen, and rest is oxygen. As I told you, what is the total percentage of any compound? That is 100%. Now, if now, first of all, what the information they have given? If they have given the information, which elements are there? Carbon, hydrogen, oxygen. So you wrote here carbon, hydrogen, oxygen. Now, what is the percentage they have given here? 38.7 for what? Carbon. Hydrogen is 9.75. And they said rest is oxygen. How will you find the rest? You will add these two and you will minus it from 100. For example, here you can see this one. 100 minus, add those. That's what this is, 51.5. So oxygen is 51.5. If you add all these three, this, so it should be equal to 100%. Okay. Now, first thing we wrote this one. Now, now you have to find the moles. You have to find the moles. And how you find the moles? For example, this number, the percentage or mass divided by AR. If you see the periodic table, what is AR of carbon? 12. What is AR of hydrogen? 1. What is oxygen? 16. So now the second step, you will divide them with their AR, mean relative atomic mass. When you divide it, what you will get? 38.7 divided by 12, you will get 3.22. When you divide 9.75 divided by 1, the same will come here. 51.55 divided by 16, 3.22. So now you got the number of moles. For carbon, 3.22. For hydrogen, 9.75. For oxygen, 3.22. So this is the number of moles you will find. Now what you will do the next? Now what you will do, you will find the smallest number of in these moles. This is 3.22, 9.75, 3.22. So which is smaller in all three? 3.22 mean they are same. Take anyone. So divide with the smaller. So it means 3.22 divided by 3.22, 9.75 divided by 3.22, then 3.22 divided by, mean you will divide all these three with the smaller number. What you got here now? 1. What you got here? 3. What you got here? 1. So under C you will write 1. Under hydrogen you will write 3. Under oxygen you will write 1. So no need to write 1. So this is what? CH3O. So this is the empirical formula of this one. Once again, in the exam, if they will say to you, find the empirical formula, they will give you which elements are present. For example, carbon, hydrogen, oxygen. Then they will give you the percentage or they will give you the mass. So here percentage given for all of them. Percentage is given. Then you see the periodic table and divide by their AR. For example, carbon 12, hydrogen 1, oxygen 16. So you will get the number of moles. So now see all these three values, which is smaller. So here unfortunately, you can say by accident two values are same and they're also smaller. So you'll divide the smaller value with all 3.22, 3.22, 9.75 divided by 3.22 like this. So you'll get 1, 3, 1, and then this is the empirical formula. Is it clear, Ahmed? Please confirm.
Yes.
Okay. Okay. Now they will say, okay, this is the empirical formula you found, but we need its molecular formula. We need its molecular formula. You know that empirical formula always shows the simplest ratio. Molecular formula tell you the complete ratio. Okay. So no need to worry about that one. So simply what you can do. For example, they have given a question here as an example. The empirical formula they have given here, you have to find the molecular formula from that. So what is the example? We will see it now here. For example, the empirical formula of a compound called hexane is C3H7. Which formula this is? Empirical formula. The molecular mass of compound is what? 86. So they gave you MR of compound. So simply what you will do, you see the empirical formula, find MR of it. How you will do this one? First of all, which elements there? Carbon and hydrogen. How many carbon? 3. How many hydrogen? 7. What is the relative atomic mass of carbon? 12. What is hydrogen? 1. So 3 multiplied 12, 36. And this is 7. So what is the total? 48. So you found it. So simply what you will do, divide the MR of compound which is given to you 86 by what? This is with this one. I think this is not 48, this is 43. Sorry, this is a mistake here. When you add 36, this will be 43. Okay. So now the MR of the compound is what? 86. And what is MR of empirical formula? 43. So what is the answer you will get? 2. So 2 is the answer here. So what you will do, you will write the empirical formula. What is that? C3H7. So whatever the answer you got here, multiply by both numbers. 3 multiply 2, 7 multiply 2. So you will get C6H14. This is the how you will find the molecular formula. Simply that the MR of the molecular formula, for example, what was that? 86 divided by MR of empirical formula, what is that? 43. Multiply the empirical formula, what was that? C3H7. So it will be answer is 2. 2 multiply here, 2 multiply here. So this is the answer. Is it easy? Please confirm if you get it. Yes, Ahmed. If any doubt, I can repeat it. Okay, good. So this is how you will find the molecular formula if empirical formula is given. So from here you can find molecular formula only if you know the empirical formula and they also give you the MR of the compound. So you need these two. If this is not given, so you cannot find. So but in the exam they will give you this one. Okay. Now the mole ratio. What is the mole ratio? A mole ratio is a ratio between the amount in moles of substance involved in a chemical equation. The mole ratio is determined by using the big numbers before the symbol in the balance equation. For example, now they have given equation. What is the equation? Nitrogen is reacting with hydrogen and giving you ammonia gas. This is NH3. So if you want to balance it, so you put 3 here, put 2 here, now it is balanced. And if you want to check how it's balanced, how many nitrogen here? 2. How many nitrogen here? 2. How many hydrogen here? This number will multiply by this, it means 6 hydrogens. And how many here? 2 multiply 3, 6 hydrogen. So this equation is balanced. First of all, you will make sure the equation is balanced or not. After that, you will see the mole ratio. I told you whatever the number is here before the symbol, here, here, they are moles, number of moles. For example, how many moles of nitrogen working here? Here nothing mean 1, so 1 mole. How many mole of hydrogen here? 3. How mole of ammonia here? 2. Whatever the number is given before the formula, that will be the number of moles in that substance. Now, this reaction can be read. If you want to read this reaction, how you can? I can say that 1 mole of nitrogen mixed with 3 moles of hydrogen, and they give you how many moles of ammonia? 2 moles of ammonia. So this is they are telling you. So here once again, if the actual number of moles nitrogen is 5, if instead of 1 we say we have 5, so how many moles you will get here? That is the mole ratio. In the exam they will give you the question like this. Really simple, really easy. See here. For example, now this is a question here. If the actual number of moles of nitrogen 5, then the number of moles of other substance will also change. Okay, how you will find that one? For example, now compare two things. You want to compare nitrogen with ammonia. Compare. Here write nitrogen, here write ammonia. If you have 1 mole of ammonia and nitrogen, how many moles of ammonia are getting? 2. But in the exam, they give a situation what? How many moles of nitrogen? 5. How many moles of ammonia? You don't know, put X here. Now you have to find that if 1 mole of nitrogen you are taking, how many moles of ammonia you are getting? 2 moles. If you take 5 moles of nitrogen, how much you will get ammonia? So for that you do the cross multiplication. Mean 1 multiplied by X, 5 multiplied by 2. So X equal to, because no need to write 1, 10. So this is the 10. So it means if you take 5 moles of nitrogen, it is what you will get 10 moles of ammonia. So like this, you can compare the ratios. For example, if I want to compare these two, for example, I say nitrogen and hydrogen. Now, how many moles of nitrogen in the equation? 1. How many moles of hydrogen in the equation? 3. But now, how many nitrogen they have given me? 5. How much hydrogen will be put X? Cross multiply. X times 1 equal to 5 times 3 means 1 no need, X equal to 15. So it means that here 15. So if you take 5 moles of nitrogen, you need 15 moles of hydrogen. So by this you can find the number of moles if they will give you new value. First value you will take from the equation, whatever the numbers here. Then they give you a second value of maybe they will give you for this one or for this one. Then use this comparison method and you can find the actual mole for other one. Did you get this one or not? Please confirm. Yes, Ahmed.
Yes.
Okay. Now you have question, if you can see this one. How many moles of ammonia are produced when 9 mole of hydrogen react with nitrogen? Got it? So first of all, you will make the equation. And what is the equation? You have that nitrogen reacting with hydrogen and giving you ammonia, NH3. If you want to balance it, so it should be 3 here, 2 here. It's balanced now. But now, what they're giving you? 9 moles. Ammonia they have given here. The second value, 9 moles. Now they said that how many moles of hydrogen they need. Now they are comparing two things. They are comparing ammonia and they are comparing what? Hydrogen. Compare them now. But here you have hydrogen, here you have ammonia. First value from the equation. So what is hydrogen here? 3. What is ammonia here? 2. This is from equation you wrote. Now they gave you how many moles of no, sorry, it's not that question. Sorry, we just interpreted it wrong. They said that how many moles of ammonia are produced. They need the moles of ammonia when 9 moles of hydrogen react with nitrogen. So here you will see that one. Here 1, 3, and 2. They are comparing two things. They are comparing what? Hydrogen. They are comparing with ammonia. One value you will write hydrogen how many? 3. Ammonia how many? 2. Now, other value 9 moles of hydrogen they have given. Ammonia they said find how much, how many moles. So put X. So cross multiply. So 3 times X equal to 2 times 9. And if you want to remove the, you can say 3 from here, divide by 3, divide by 3. This 3 cancel with this 3, X equal to what? 3, this is 3, 6 moles. So you will put here 6. So when you take 9 moles of hydrogen, it will give you 6 moles of ammonia. So by this you will compare. Okay. Now in the exam, they can give you the question like this, and with the help of that, you will solve that one. For example, they said, example, 1.6 gram of iron 3 oxide react completely with carbon monoxide according to the following equation. Now see, here iron is reacting with carbon monoxide, giving you iron and carbon dioxide. This is known as redox reaction. Okay, because this iron is losing its oxygen, and this is happening in the extraction of iron. In chemistry we'll do this one in the blast furnace. When you will do that, how you extract the iron from its ore, hematite. Okay, so the equation is given here. Now what is the question? They said that how much is the mass of iron produced? Okay, how much mass of iron is produced here? Now for that, okay, you need the mole ratio for all of them. Okay, now if you see here, now they're comparing two things now: iron oxide, okay, and they said that iron, this one, these two, this one, this one. So write them in here. For example, iron oxide, and here write simple iron. Okay. Now, how many moles are there in the equation? Here nothing, 1. Here 2. So 1 and 2. Now what they have given? Did they given another mole here? I will put right here and put X here. No. They gave us 1.6 mass of iron oxide. Now we will see the formula of what? Mole and compounds. What was that formula? If you want to find the mole of a compound, so what will you do? You will write mass divided by mr. Mass is what? 1.6 divided by mr of iron oxide. If you do it, so it will be what? It will be that 50 means 56 multiplied by 2 multiply this one. So it will be 100. For example, why? Once again, if you want to find mr of what? Iron 2 oxide. So first you will write iron, then you write oxygen. How many atoms of iron? 2. How many atoms of oxygen? 3. What is the relative atomic mass of iron? 56. What's the relative atomic mass of oxygen? 16. So if you do it, it is 1, 1, 12. And if you do this one, 48. Add both of them. So mr of Fe2O3 equal to what? It will be 20 and 40, 160. So this is the mr you found. Now you have 1.6 divided by 160. So then what you will get? The answer is 0.01 mole. That you will write here. If you have 0.01 mole, how many moles of iron you will get? Put X here. Now do the cross multiply. What you will do? X multiply by 1, then 2 multiply 0.01, and X equal to what? 0.02. So this much of iron you will get if you will burn this one, but this is in what? Moles. You can convert this moles into mass. So how you will do? Just multiply it. For example, here you have 0.02 multiply with iron, you will get. So if you burn this much of iron, so you will get this much of the iron from this one. So this is, maybe you are feeling it difficult little bit because you will have to practice them. When you practice them, inshallah, you will feel it easy. So here they have other examples are there. So you will go through this one and then you will know it better. So till here, any confusion?
No.
Okay. After that, you have limiting and excess reagents. This one they are using. Reagents mean reactants. No need to confuse this one. When they're talking about reagents mean they're talking about reactants. Limiting reagent. For example, you are making a reaction. Okay. One of the elements, one of the reactant finish early, and due to that reaction is stopped. So that is known as limiting reaction. For example, now you have two, let's say bread, and you have 3 hot dogs. You want to make a sandwich. And how you make the sandwich? In one bread, you have 1 hot dog. Then again, in one, you have 1 hot dog. So what is left now? Which thing is finished? Hot dogs are finished? All? No. 2 hot dogs are finished, but one is left. What about bread? Bread both finished? Can we make another sandwich, Ahmed? Two we already made. Can we make another one? Ahmed, we make two sandwiches. Can we make another one?
No.
Why? Because bread is, we don't have
As
bread.
no,
So,
no,
yes,
not enough.
not enough. So it means that which stop you to make the bread? Which thing stop to make a sandwich? Which thing stop you to make the sandwich?
The bread.
The bread. So anything which is finished early in the reaction and you cannot make the reaction further, so that thing is known as limiting reagent. That is known as limiting reagent. So here the bread stop you to make more sandwich. So here this is known as limiting reagent. And the other thing which still left behind, which is more and it's not finished, that's known as excess reagent. Got the difference between limiting and excess?
Yes.
Okay. In the same way, when they are making the chemical reaction, so some of the reactant they finish early, and due to that reaction will stop. So that is known as limiting reagent, and other one which is still is there, that is known as the excess reagent. Okay. Now, how you will find, if they have given a equation, how you will find that this is limiting reagent and which is in excess? Simply they have given a question. Now see, now follow these steps to determine the limiting reagent reactant in a chemical reaction. Number one step, convert the given amounts. If mass is given, volume is given, concentration is given, convert into moles. What is the first step? Whatever the value they have given you. If they have given you the mass, so what is the formula to convert the moles? So mole equal to mass over AR or MR. If it is volume, so it is volume over 24 like this. So in the same way, first thing this one, whatever given, convert it into moles. Number two, use the mole ratio, determine which reagent is fewer moles. See here in this equation, for example, you have to find which is less. How? For example, now see the question. Example, 2.4 gram of magnesium react with 2.4 cubic decimeter of oxygen according to the equation. So you see here, this is magnesium reacting with oxygen and this is this one. Got it? So now you have given mass and you have given volume. What is the first step? Convert them into moles. Now, how much? 2.4 grams of what? Magnesium. If I want to convert into moles, so how I will find moles? Mole is what? Mass over AR. What is mass? You have 2.4. What is AR of magnesium? 24. So when you find the answer 0.1 mole. So this is what? The mole of magnesium. Now oxygen. Oxygen is how much? We have here volume of oxygen is 2.4 cubic decimeter. I need the moles. What is mole? Volume over 24. So it means 2.4 divided by 24, again 0.01. So I converted magnesium also into moles and oxygen also. The first step is completed. Got it? Now do the second step. I will compare them. See now. Okay. Now moles. How many moles we calculated magnesium? 0.1. For oxygen, we just calculated 0.1. Ratio of mole from equation. If you see the equation, okay, what is the equation? You have magnesium reacting with oxygen, giving you magnesium oxide. So you would put 2 here and you put 2 here. So from the equation, how many moles of magnesium? 2. I wrote here. How many moles of oxygen here? 1. I wrote it here. So 1 mole I calculated just right now here, and other mole I am taking from the equation. Now compare them. 0.1 divided by 2. These two. 0.1 divided by 1. So what are the answer I will get? 0.05, 0.1. Which is less? 0.05 is less than this one. So if this is less, so magnesium is limiting, and which is more, that is in excess. Any confusion? Did you get this one? Yes, Ahmed? Got it?
Yes.
Then you have the percentage yield. Percentage yield mean product. When you are making a chemical reaction, for example, now very simple, I will tell you that Ahmed, okay, Ahmed, take 1 kg mango and take 1 kg milk. Okay, now make me the mango shake. I mix and in the blender and mix them. So normally 1 kg mango, 1 kg milk. So what is total? 2 kg. What do you think? The shake which I will get, it will be 2 kg or less? Tell me. Yes, Amal. If I bought 1 kg mango from the market and I bought 1 kg milk from the market, if you, I will total there 2 kg. But when I will bring home, I will just bring them home. I wash them. I will peel the mangoes and then I will cut them into pieces. I put in the this jug, then I will make the shake. It will be 2 kg or less than 2 kg.
Less.
Less. Why? Because some of the mango they are wasted, because when you remove you peel them, then maybe seed also go out. So whenever you do a chemical reaction, it does not mean always you will get the same product. For example, if you have A making reaction with B, so you are getting C. So if you are taking 2 gram of A, 2 gram of B, so you will get 4 gram of C. No, because some of the reactant they are wasted. Maybe when you are making reaction, some of them fall down, maybe some of them stick with the container. So anything, so there nothing, no, never you will get 100%. So you will get the percentage yield. So what you will do, that there are using two techniques, two term: theoretical yield. Theoretical yield means you are doing something on paper. For example, what you will do? Okay, I have sodium and chlorine. Okay, I will take 30 gram of sodium. I will take 20 gram of chlorine. So I will get that how much? 50 gram this one. So this is I am doing on paper. I am doing on paper calculation. Okay, I will do the experiment like this and I will get like this. So on paper, whatever the product I'm getting, that is known as theoretical yield. Known as theoretical yield. I mean, just according to the theory, I'm doing this one. But when I went to the lab, I did this experiment. But when I mixed this one, so I got only 46 gram of NaCl. 4 gram is wasted due to some reason. So whatever I will get actually after the experiment, that is known as actual yield. Now I need the percentage yield. Very simple. Actual yield mean what? 46 Divide by theoretical yield. What was that? 50. Multiply by 100. So that will be the percentage yield. Got it?